Our first graph analysis question was from the 2015 exam. The mean score is 3.75. And in this question, I'm given a derivative graph. So this is f prime. And I am told that the area from -2 to 1 is 9. So the area of this region is 9. And from 1 to 4, the area is 12. In part A, I want the x-coordinates where f has a relative maximum. So I'm asked where f has a maximum, yet I'm working with an f prime graph. You can use the fun chart to help you decide where the maximum is. So on this one, we could look and see that a max is going to occur in between this column right here. So you can see f has a max where f prime goes positive to negative. So on this graph, I can see that f prime goes from a positive value to a negative value right there at x equals -2. So my answer here is going to be f has a relative max at x equals -2, and my reason is f prime goes from positive to negative. A couple things on this one. You do not have to put this in a sentence, so you don't actually have to say that. You could just give that x value. You do, however, want to mention f prime, so make sure that that is part of your explanation. And also, if you don't like the symbols, you can always just write out the word positive and negative. In part B, I'm asked on the open interval where f is both concave down and decreasing. And again, a fun chart will help me visualize this. So I know that f is concave down where my derivative graph f prime is decreasing, and f is decreasing where my derivative graph is negative. So I'm looking for intervals where f prime is below the x-axis and also on a downward trend. So that's going to be from -2 to -1 and also from 1 to 3. Make sure you name both intervals. It would be okay if you put brackets on these, but you have to have both of these for this one point, and our reason is simply what we were looking for, where f prime is decreasing and negative, and again, you must mention f prime in your explanation. In part C, I'm asked for the points of inflection on the graph of f. In the fun chart, if you like to use the fun chart, our point of inflection is happening in between these two columns right here. So on the graph of f, it's a change in concavity from up to down or the other way around. On the graph of f prime, it's from an increase to a decrease or the other way around. And on an f double prime graph, it's where that graph goes from positive to negative. Since this is an f prime graph, I'm going to follow what this middle row says right here. And I'm going to find where f prime goes from increase to decrease or vice versa. So f prime is decreasing, decreasing, decreasing until I get to -1, and then it increases until I get to 1. Then it decreases again until 3, and then increases. So every time it makes a transition from increase to decrease or the other way around, I have a point of inflection. So my points of inflection are at -1, 1, and 3. And so you just give your 3 points. Your reason is just f prime goes increase to decrease or vice versa. Make sure that you give all 3 points to get this 1 point. If you're missing one or if you have an extra one, you just don't get the point. Make sure you mention f prime in your explanation. An alternate explanation would be f has relative maximus min points at these x values, because that's what we call it when f prime goes from an increase to a decrease. That's a max, or decrease to an increase, that would be a min. So this would be a completely acceptable explanation for those points of inflections as well. In part D, I'm given f of 1 equals 3. I'm asked to write an expression for f of x and then use that expression to evaluate two function values. On this one, this is where I'm going to use my twist on position. So f of x equals some known value, which is our f of 1, plus our integral's lower limit is going to be the 1, and the upper limit is going to be the x. So my integral is going to go from 1 to x. And what belongs as the integrand is the derivative of whatever is sitting out here, which is f prime. Because x is used for the upper limit, I have to swap out and use a different variable in here. So I'm just calling it t. If you mistakenly put x in your integrand, I don't think it would cost you a point. I think you would still earn full points for it, even though technically it's not quite correct. What you get point-wise is a point for this integral, and then you get a point pretty much to add that initial condition. It would be okay if, just from the get-go, if you write a 3, just put the value in place of the f of 1. I like this function value because that 1 tells you exactly what that lower limit's supposed to be, but you can jump right to that 3 if you want to. And now I need to use it to find f of 4. So in place of my x value, which is my upper limit, I'm going to put a 4. And that was the problem with putting an x in that integrand, because we're not plugging the 4 into that position, we're plugging it into the upper limit. So this becomes 3 plus my integral from 1 to 4 of f prime. The way to evaluate this integral, I'm going to use the area interpretation. So I'm going to refer to my f prime graph. And from 1 to 4, I can see I have an area of 12. But because that area lies below the x-axis, I'm going to take it as a negative 12. And 3 plus negative 12 gives me that final answer of negative 9. I'm now asked to evaluate f of negative 2, so I'm going to follow the same process. Replace the upper limit with a negative 2. When I do that, I see my limits are reversed. The lower limit should be the lower number, so I need to put them in the correct order, and that introduces a negative in front. And now I evaluate this integral using the same way. From negative 2 to 1, I'm going to look at the area. So from negative 2 to 1, my area is 9. But because that area lies below the x-axis, I'm going to take it as a negative 9. Along with the negative from the limit reversal gives me a 9 plus 3, and my final f of negative 2 value is 12. Point-wise, you have to get both of these values correct to earn this point. If you get one and not the other, you just don't get that point.